Developed during World War II, radar rapidly became an airplane's worst enemy. By generating a pulse of energy that blankets a portion of sky, radar looks for any object that bounces back the energy it emits. The emitted signal bounces off the flying object, some of it coming straight back to the source. Conventionally, the same antenna is used for both transmitting and receiving. And though the signal returned is usually weak, it can easily be amplified. Because of this, radar can detect objects from greater distances than other sensors. By comparing the bounce-back times of the signal collected by the receiving antenna, information about the size, shape, direction, and speed of the target are formulated. This is called a radar signature. But most important of all, it pinpoints location. Planes had always been targets, but radar made them even more vulnerable. By the early 1950s, as the Cold War between the United States and the Soviet Union heated up, the need to evade radar intensified.
Marked by the unveiling of 5 new missiles.
The CIA needed a spy plane that could conduct secret flights. The first idea of stealth was to have a plane that flew so high that even if detected, it would be out of range of enemy aircraft and weapons. By the mid-1950s, the U.S. had its new aircraft, the U-2 high-altitude reconnaissance plane. An aircraft that could fly at the edge of space, an altitude of more than 70,000 feet. An aircraft that could fly at the edge of space, an altitude of more than 70,000 feet. The edge of space, an altitude of more than 70,000 feet. An altitude of more than 70,000 feet, and 70,000 feet, and 70,000 feet. It was stealthy because at such heights it was thought to be beyond the reach of detection. But the United States would learn that flying high wasn't enough when Gary Power's spy plane was shot down in Soviet airspace in May 1960.
Behind me is the reason why stealth is important. This was a hard-learned lesson by Gary Powers of the U-2, the surface-to-air missile. This one in particular is the SA-2. This is why stealth is important. These could track, attack, and shoot down American airplanes.
To defeat this threat, U.S. planes needed to become still more difficult for radar to detect, leading to the concept of low observability, more commonly known as stealth. The stealth-like successor to the U-2 was another high-flying spy plane, the SR-71 Blackbird, designed specifically to lower its radar signature and painted with a new top-secret material.
Then they went to a stealth paint that had tiny iron balls. We called it iron ball. What it did is diffuse the radar so that if you were looking at it as a radar technician, you would see a cloud, you wouldn't see an aircraft, but it was traveling so fast, it was very hard to distinguish that you had an aircraft from the radar beam.
And though still classified, the SR-71 is believed to have a radar cross-section or signature about the same size as a standing human. But its trump card was performance. The Blackbird not only flew at the edge of space, but flew faster than any other aircraft. When flying at 2,000 miles per hour, it was traveling faster than a bullet fired from a .30-06 rifle. Blackbird not only flew at the edge of space, but flew faster than any other aircraft. When flying at 2,000 miles per hour, it was traveling faster than a bullet fired from a 30-06 rifle.
There's a great sign over the 9th Strategic Reconnaissance Wing in Kadena during Vietnam, and it said, "Yea, though I walk through the valley of the shadow of death, I will fear no evil, because I'm at 80,000 feet at Mach 3. Because I'm at 80,000 feet at Mach 3. Because I'm at 80,000 feet at Mach 3. Because I'm at 80,000 feet at Mach 3.
Satellite reconnaissance would eventually take over the SR-71 spying mission. But the quest for invisibility lived on.